All right, so welcome back, everybody. So today we're going to talk about the strategy and the adapter design pattern. Move this over a little bit. So here's a problem. So suppose you want, so let's say you have different ways of solving like the same problem. So for example, there's different ways of searching a list. You can use linear searching, you can use binary searching. When it comes to sorting, there's different ways of sorting. So you can use bubble sort, insertion sort, and all the different algorithms that are out there. So essentially, you have different ways of solving a problem, and each one has its own pros and cons and use cases and different contexts in which it can be used. And you want to be able to dynamically select at runtime which particular solution that it is that you want to use. So let's say, again, using that example of sorting numbers, there's bubble sort, which is really inefficient. Then there's quick sort, that's really fast. And then I think it's selection sort that uses like the least comparisons or something. So there's different trade-offs, and you want to be able to pick the right one based off of your needs. So, and you'd like to decide at runtime which algorithm that you want to use. So the problem is, how do you accomplish this using, inheritance and classes and all of that, and make it as maintainable as possible? So this is where the strategy pattern comes in, and this is a type of behavioral design pattern. So the idea is that let's make a generic interface that has a generic method. So let's take the example of the sort. So you would have like a generic sorting method specified in an interface. And then what you would do is you would have different sorting algorithms, each in its own class. So you would have a class for selection sort that implements that interface. Then you would have one for bubble sort, merge sort, and basically any sort that would implement that interface and provide its own sort implementation. And then what you need to do at, sort of in your main program or at runtime, what you can do is you can instantiate the particular instance of the generic sort, or you can instantiate a particular instance of the generic sort class, and then you can use that appropriately. So we'll see an example of that. So let's take the example of array searching. So let's say you have a list of students, and you want to be able to check if a given student exists. Now, there's different ways of searching a list, like I mentioned. So you can either use a linear search, or you can do a binary search. And anybody know what the precondition is to use binary search? Yeah, so your list has to be sorted, right? So there's a sort of runtime check that you need to perform before you can go ahead and use binary search. So that's the example we're going to go with. And again, we're going to use binary search if it's sorted, linear otherwise. And basically your different searching techniques, which are going to be basically concrete implementations of a app or of an interface, these are referred to as our strategies, and that's where the name comes from. So here's a look at the UML of what that's going to look like. So we start off by defining a strategy interface. So I called it I array search strategy. The I is just for specifying it's an interface, and it's a generic type. So it has a single method which takes in a list or an array of type T. So like any type, it can be a string, int, and so on. And then you pass it another value which is also a generic type, which is going to be the value that you want to search for in the list, and this returns an index of where that element was found in the list, which is just an integer. So that's like our abstract interface, like at the top level. So again, that's not going to provide any implementation. Then what we're going to do is we're going to provide concrete implementations into classes that implement that interface. So we have a linear search strategy, and then we have a binary search strategy, and each of those are going to implement the search method, and each of them are also going to implement that class with a particular type, because the array search strategy is of type T, so it's generic. So the linear search and the binary search is going to use a type student, which we define here. It's not super important. This is just for the sake of example. It's just, it has a name and age, and it has a get name and a get age method. And then basically what's referred to as in this pattern a context class. A context class is essentially one that has an instance of a particular strategy, and then you can use that strategy and you can change that strategy. And in our example, this student DB class is what serves as a context class. So if you see, we have two private members. We have a search strategy, and we have students, which isn't super important. It's just a list of student objects. But this is the important part, which is a search strategy, which is basically an instance of I search strategy. And so you can imagine this can be a linear search strategy, binary search strategy, or whatever else that you want to add. And then we have three simple methods called add student, does student exist, which are, again, for the sake of example, the one that's actually important is the set search strategy, which takes in a parameter of type I array search strategy. So you can imagine you can pass it a particular instance of a search strategy, and then it will update this private member in the field to use that strategy. And then we would actually use that in does student exist by calling the search method. So again, we'll look at the code and it'll make sense. Any questions so far? Can you guys see the screen? Yeah. It's basically a class. So you notice that there's a aggregation relationship here. So essentially, you can define it as a class that has an aggregation relationship with your with sort of your strategy interface. And more precisely, it's one that it has an instance of a search strategy, and it can change that strategy, using the set search strategy, and then it will invoke an actual strategy. So what we're going to do in a second is in the does student exist, you can imagine what we're going to do is we're going to call search strategy dot search. Okay, so it basically has an instance of a strategy. It can invoke that strategy. It can change that strategy. Okay. Any other questions? And again, that has an aggregation relationship because if you remember, we talked about the different relationships, and that has an instance of array search strategy. But because array search strategy can exist independently, that's an aggregation relationship rather than composition. Same idea here, but this one isn't super important. This is just for the sake of example. Okay, good so far? Okay, we'll come back to this. Let's look at the code for the student example. So the first thing we had, let me get rid of this and this as well. So the first thing we had was the search strategy interface. So let's go ahead and make that. And let me change the color theme. It's better. So we have array search strategy. This is a generic interface. So the way you specify that is using this type T, which can be any type. I think you guys have seen this in your assignments or lecture. And then we specify that method, which was the public int search. So, and that takes in, we're going to use array list rather than an array, just to make our lives a bit easier. So this is going to be an array list of type T, and let's just call it vals for values. And it's going to take in a T, which we'll call the target, which is the element that you want to search. And we're going to rename this to interface. And so that's our method. So again, we're just following that UML diagram. Then we had the linear search strategy and the binary search strategy. So let's make those. And let's make the binary search strategy. So again, these are basically concrete implementations of the strategy interface. So again, these are going to implement that array search strategy interface. And again, they're going to provide a, because array search strategy is a generic type, we have to specify which type. So we're going to use the student type, which we'll create in a second. And same thing here. This implements array search strategy with type student. So let's make the student class. And so far what we've done is these three things. Now let's do the student class. So we have student.java. So let's make our constructor. And again, this is going to take in a name and an age. Take variables for that. So private string name and private int age. Then let's just set those in our constructor. Then we just have two getter methods. So public string get name. This is just going to return, or we can just do name. No. And then we have public int get age, which just returns age. Okay. So if you look at our diagram again, we've done these three things. This one, now let's go ahead and do the student DB. And we still have to implement like the actual search function here. So we'll get back to that. So let's take a look at student DB now. Student db.java. So anyone remember what the two class members were for student DB? The student what, sorry?
I'm not sure what the second one is.
Yeah, that's sort of the obvious one. The other one, which is the important one. Anyone remember that? So it has to do with the search strategy. No, like it has to do with it's going to hold an instance of something. So again, it's going to be an instance of a particular I search strategy, okay? Which can be again linear or binary. We'll see how that works in a second. So we have that. We have students, and let me import array list. And so basically we have private I array search strategy. And we'll just call this search strategy or just strategy. And we can instantiate it right away. So this would be new, or no, we wouldn't instantiate right away. We would instantiate this in basically the set search strategy. So yeah, we wouldn't instantiate this right away. So we have the does student exist, which is a Boolean method. Does student exist? We're going to pass that a student object. So we'll look at the implementation in a second. Then we had the public, we had the add student. So that's also going to take in a student. And there was a third one, which was which is really the important one, which is a public void search strategy or set search strategy. And that's going. Anyone know what the type would be here? What the type of the parameter that you would pass to this? Yeah, the I array search strategy interface. Yeah. Or another question is why wouldn't you just pass like an array of a parameter of type linear search strategy? Yeah, exactly. So you want it to be generic again. So yeah, just keep that in mind. So you would use I array search strategy, and let's just call it strategy. So we've added all the classes now. Next, let's take a look at let's do this class first, and then we'll do the actual search implementation. So anyone know what we're going to do in add student? Any questions so far? I might have gone too fast. So I was just setting up the classes. We haven't really done the really important stuff yet. So this is just setting up the classes. So anyone know what's going to happen in add student? Yeah, literally, you just add student. So students.add student. We're just going to keep it simple. Don't worry about duplicates or anything. What about student? Does student exist? So this is where you'd actually have to use your strategy. So anyone remember what methods the strategy interface provides? Well, there's only one, which is the search. So if you remember, the search returns an int. So if you want to check, and I should have mentioned, it'll return -1 if it doesn't find the element. So that's a little hint. So what's going to happen in the does student exist? Yeah. What would we call though? Sorry? Yeah, that's perfect. Yeah. So what we do is return strategy dot search students and student. So students is our class member, which holds a list of students, and this is a particular student. And what we would do is return that does not equal -1. So if that isn't -1, that means we found the student. And this one is straightforward. We would just update our strategy, or let's do strategy. Okay. So pretty straightforward. Any questions? So now let's go ahead and implement the actual search strategies. So let's look at the linear search strategy. So we're going to have to, implement that search method. So we had public int search. Now we're going to pass in an array list of students. Student and student. And if you remember, these were called vals. And this was called target. Let's import array list. Anyone want to give me this method? This is, it's like programming 101. I can't hear you. Yeah, just a simple for loop. So let's do I is less than, yeah, size I plus plus, and then if vals dot get I. So this is a list of student objects, so you have to call the get name. So get name, if that equals, let me do this separately. Let's do string name. So vals dot get I dot get name. So again, we have to call a get name because it's a list of student objects. So we're not just comparing like numbers directly or something. And then if current name, sorry. Again, don't worry about duplicates. We're just keeping it simple. So if current name dot equals target dot get name, and we return. And again, if they do have the same name, you would just return the first one that you find, right? So you would return the I here, the index I, and otherwise we return -1. Okay, pretty straightforward. Now let's look at the binary search one. So again, we're gonna have, let me copy the method signature. So anyone remember how binary search works? You guys have seen binary search, right? Yeah. So what do we initialize high to? We have the low, which is the beginning of the list, and then basically we're going to go until they don't cross, the 2 pointers don't cross each other. Then anyone remember what we do first? Yeah, so we find the middle. And then basically we do if, let's do string current name equals vals dot get mid dot get name. And then we're going to compare that to target dot get name. So let's do if, so here we have to use the compare to method for objects because we're comparing strings. So we have to do if target name, which is target dot get name. So let me make that up here. Target dot get name. So if target name dot compare to current name. So this is going to return. I actually wrote this down so I don't forget. This is going to return less than 0 if target. So yeah, if target is less than current name, like in terms of like lexicographically, then it will return a negative number. So that basically corresponds to the case when target is less than mid, if you're just searching for numbers. So in that case, if target is less than the mid, then you would just shrink your upper index high to the mid -1. So you would do high equals mid -1. Else if, and let me just copy that. It returns a positive number if target is greater than mid. So in that case, you would just update your lower bound to mid +1. Otherwise, we return mid because that means they're equal. And otherwise, we just return -1. Any questions about this? So again, the compare to is just for comparing objects. In this case, we're comparing strings. So again, this returns less than 0. And the way the compare to works for strings is if this one, the one that we call the compare to on, is lexicographically less than the current name, then it returns a negative number, otherwise positive. If they're equal, it returns 0. Okay, any questions? So now let's go ahead and use this. Let's make a main method where we can use this. So let's first of all make the student DB. Let's call it DB. And then let's go ahead and create some students. And let's see, let's make a student called Alice. Hopefully no one here is named Alice, so I don't need to call you out. Then let's make one called Bob. Say they're 21 years old, and let's make one other. Let's call him Charlie. Very creative names, I know. Charlie's 23, and then we're going to go ahead and just add these to our DB. So db.addStudent, and then let's just copy that. Bob and Charlie. Now let's go ahead and actually use our, so let's say we want to check if Charlie exists in the DB, in our student DB. How are we going to approach that using everything we've made so far? So we want to check if Charlie exists in DB. So using everything we've seen so far, anybody know? Yeah, so if you look at our DB, we're going to have to call student, does student exist? But there's one thing we have to do before that. Sorry? Yeah. So let's go ahead and make the student, well, we already have the student DB. So basically what we're going to do is db dot does student exist, Charlie. But before we do that, we have to set the strategy. So we're going to have to do db dot set search strategy. And what are we going to pass here? Anybody other than those two have an idea? Yeah. Yeah, or linear, right? Whichever one we want. So let's just say you want to use linear. So we'll pass an instance of that. And if you look at our, so what's going to happen here is you call set search strategy. And then if you look at our student DB, it's going to basically set that equal to this class, this member strategy. And then when you call does student exist, it has an instance of linear search strategy, and it's going to call the search method for linear search strategy, which will execute this code. So any questions? Let's go ahead and run that. So let me know if you have questions, and we'll do one other example of that. With this, let's do, whoa. Oh, let me get rid of this. For some reason my linter isn't running, so it's not catching any errors. Okay, give me a sec. So we didn't import that in some places, so let's add that. Okay, and yeah. Students.add.
The student database class, like student.
Yeah. Okay. Now let's try that again. So let's run Java app, and null pointer exception. Let's go ahead and instantiate that. Yeah, we can instantiate it directly. Yeah, thanks for pointing that out. Whoever pointed that out. Let's try again. Yeah, my linter isn't running today for some reason. Okay, so you have Java app. We have to actually print. So let's do print line. Get rid of everything. So it returns true as we expect. And you can imagine if I get rid of that and I do, let's compile it again, it says false now. Okay. Any questions about this? So, like I mentioned, you might want to decide at runtime, based on some checks, what specifically which strategy you want to use. So, we mentioned that binary search can only be used if the array is already sorted. So let's just use that example. Let's just make get rid of this. Let's just make a private method that will basically check if an array is sorted. So let's do private static. This would return Boolean is sorted. And we're not actually going to implement it. We'll just keep it simple. Let's just do return true for now. And then you can imagine what you might want to do is if is sorted, then you do db.setStrategy. Instead of linear search, you would use binary search. And then otherwise, you would set linear search. So that's one example of how you would use this sort of dynamically, and then assign your strategies at runtime. Okay, any questions? Everything's clear? Okay, so quickly to recap, so for the strategy pattern, we have a generic interface that specifies some generic behavior. In our case, it was searching a list. Then we had concrete implementations of that interface with the linear search and the binary search. Then we just had a simple student class and a student DB, which isn't super important. That was just for the sake of example. But what's important about this class, the student DB, which is our context class, it holds an instance of a particular strategy. It can execute that strategy. So let's actually look at that. Student DB. So it holds this instance of a search strategy. It can call that strategy in this search method, and then it can update that strategy, anytime you want, basically. We just call the set search strategy. And then we saw an example of that, how, this is one example of something you might want to do, like check if the list is sorted, and then you call the binary search strategy, otherwise this strategy. And then you can imagine you can extend this to like anything, right? So this is just a simple local method call, but you might want to call like an external API, a database or something, and run some checks, and then based off that, instantiate a particular instance. So let's move on now. Here's a more practical example of how strategy is used in practice. So Passport.js is a JavaScript library. Anybody familiar with JavaScript? Anybody used it before? Yeah, a couple people. So it's basically a very popular authentication library. So it's very likely that anytime you've used like Google sign-in or Facebook sign-in or something on some third-party website, you've probably seen how you can sign in with Google or some other third-party service. It's very possible that this was a library that was being used under the hood. So essentially what this library does is it defines a strategy class, and it has a single method called authenticate. And then you can imagine what all these different strategies are is like Google sign-in, Facebook sign-in with your email, sign in with Dropbox or GitHub, all these third-party authentication services. And then essentially what each of those third-party authentication services do, those are like your strategies, and they all simply just implement that strategy interface and they implement that authenticate method. So something like Google would go ahead and implement authenticate and add their whole sort of all their code and the logic required to authenticate with Google. So that's a practical example, and let me just show you that really quickly. Let's open this. So if, this is a really simple library. I know it is a different language, but let me just show you it really quickly. It has a single class called strategy.js. And you can see that, I know not everybody's familiar with JavaScript, but it has a single method here called authenticate. And what it says is strategy authenticate must be overridden by subclass. So it's a simple class called strategy up here. And don't worry, I know it's called function. In JavaScript, classes are actually functions. But basically, it has a single strategy class, and it provides you that authenticate method. And that's this entire library. That's all this does. So that's it. It just has a single method. And then you can imagine all these third-party services, they extend that class, or rather implement that class and provide a implementation of authenticate. So let's take an example. Let's look at an example of that. So here's an example of this library called Passport Google OpenID Connect, and it has the strategy.js class. And then what it does is, if we scroll down a bit, it has this strategy.prototype.authenticate, which is basically overriding or implementing the authenticate method that was defined in that top level interface. Okay, so that's a more practical example of this pattern. And it's very likely that you've encountered it. Okay, any questions? All right, let's move on.